Here we're looking at lesson 3.2, which is titled Solving Linear Equations by Graphing. There are many ways to solve linear equations by graphing. This is only addressing one particular way. This is when you're given an equation that only has an x value and you are asked to solve. So you can solve using algebra and then you can graph. So we're going to go over that. So this, you're asked to solve the equation by graphing. So what they suggest you do if you're asked to do this is to find the related function, which they explain this a little bit in the textbook, but they told us that 0 in this case, so if you see 0 in the problem, is going to represent y. Or they also say f of x, because remember y and f of x means the same thing. So we can replace this with y. Okay. And then we're going to make a table to be able to graph. So our table can include any x values that you'd like, as long as there are 2. So let me erase this. And we're going to plug in the x values in the table, and I just picked these x values, so you can pick any numbers that you'd like as well, as long as there's at least 2, so that you're able to graph the line. So you're going to plug in the values for x to be able to find the y, and then the x comma y, if we set that up, will be your ordered pair that you graph on the graph. So I'm going to start with 0. If I plug in 0 for x, I have y equals 2/5 times 0 plus 6. So that's going to be y equals 2/5 times 0, which is 0, and 0 plus 6, which would be just 6. So my first ordered pair is going to be 0, 6 that I graph. And then I continue to plug in each value for x to find y. So I'm going to replace the 0 with 1 now. And 2/5 times 1 is 2/5, so I have 1 times 2/5 is 2/5, and then 2/5 plus 6 is going to be 6 and 2/5. So you can write that as a fraction, or you can do 2/5 as a decimal, which would be 0.4. So you could write 6.4. But that would be your second ordered pair. It would be 1, 6.4. Then we're going to keep going. Plug in 2. That's going to give us 2 times 2/5, which is 4/5, and 4/5 plus 6 is 6 and 4/5. And again, we can write it as a fraction, or we can write it as a decimal. So 4/5 would be 0.8. So my third order pair is 2, 6.8. I'm going to keep going. Plug in 3. So that's going to give me 6/5 plus 6. We need a common denominator, so we have 5 could be our common denominator. So 6/5 plus 18/5 is going to give us 24/5. And 24/5 is going to give us 4.8. Oh, whoops. I did my math wrong. It's not 6 times 3, it's 6 times 5, so 30/5, which is going to be exactly 6. 36 fifths. Oh, man. Okay. 30 fifths plus 6 fifths is going to give us 36 fifths. And 36 fifths is about 7.2. So we're going to have 3, 7.2. And then our last one, plugging in 4, that's going to give us 4 times 2 fifths plus 6. So 8 fifths plus 6. And again, we're going to need a common denominator. So we multiply by 5. And we get 38 fifths. And again, you can write that as a decimal. And that's going to be 7.6. You can also see that since it's a linear equation, it's going to have a pattern. So you can see that it goes up by 0.4 each time, or 4/10. And then your graph is going to just include the 5 points that I just found. So we're going to graph those. Since I only have positive numbers, I'm going to just do the positive version of the quadrant. So 1, 2, 3, 5. And then I probably want to go and look at my y values here to determine my y scale, and I would probably go up by 0.4. That would work. So since I am going to jump from 6 and then go up by 0.4 after that, I'm going to need a break in my graph. So the first term is going to be 6, and then we're going to go up by 0.4. So 6.4, 6.8, 7.2, 7.6, and we'll stop at 8. And then we're just going to graph the ordered pairs. So we had 0, 6, 1, 6.4, 2, 6.8, 3, 7.2, and 4, 7.6. And I'm going to put a point at each ordered pair. So 0, 6 would be right on the line. Then you have 1, 6.4, 2, 6.8, 3, 7.2, and 4, 7.6. And I'd connect these since I'm graphing an equation, and that would be my line. Now I have another equation here that I would graph, and I would do the same process again. So the first thing I notice is that everything's on one side and it's equal to 0. So since it's in that form, I'm going to replace the 0 with y. And this is the... So I replaced the 0 with y, and I'm rewriting the problem. And I'm going to create a table, just like I did with the last problem, to come up with my ordered pairs to be able to graph. And again, the numbers I usually use are always 0, 1, 2, 3, 4 if I have a choice, just because they're pretty low and they can be easily substituted in to calculate our answer. So we're going to plug in 0 for x first, and 0 times negative 1.25 is 0, and 0 plus 3 would be 3. So my first order pair is 0, 3. And I'm going to continue to do that. So now I have negative 1.25 times 1, which is negative 1.25, and then that plus 3 is going to be 1.75. So my next point is 1.75. We keep going. 2 times negative 1.25 is negative 2.5. So negative 2.5 plus 3 is positive 0.5. And my next ordered pair then would be 0.5. Then I'm going to continue plugging in 3. Which is negative 3.75. So negative 3.75 plus 3 gives me negative 0.75. I'm sorry, I have to pause it here because my cat is walking all over my board. Hold on. Okay, so it's negative 0.75. So that'll give me 3 negative 0.75. And then I'm going to plug in 4. So 4 times negative 1.25 is negative 5. And negative 5 plus 3 is going to give me negative 2. So each time I'm going down by the same amount, it looks like. And I'm going to graph this. Whoops. So I'm going to graph those ordered pairs. I need to think of my scale. So my scale is going to be by ones for the x values. Whoops. And then I probably want to do something smaller for my y values. So I chose to do by 1.25 because that's the pattern that I saw when I was plugging in the values. So my scale is by 1.25. So I labeled my scale. Now I'm going to plot my ordered pairs. So I have 0, 3. That's going to be about here. Then we have 1, 1.75. About here. Then we have 2.5. And 3, negative 0.75. And then 4, negative 2. And again, it should make a straight line, so we're going to connect it since I'm graphing an equation, and that would be my answer. The next part is, again, we have only an x value in this equation, so we're supposed to solve by graphing, but what this equation example is for is to show you that when you see the exact same variable terms with the x there as the other side, so they're both 4x, okay? Even if they're opposite, this won't work, so it can't be 4 and negative 4. It would have to be the positive 4x and positive 4x. So it would have to be the exact same term on both sides, but different numbers. We actually learned about this already, but this is a reminder that that would be just no solution. So we would not need to graph that if this is the case. Again, we look at this example, and this says 2 minus 3x equals 6 minus 3x. So that again makes negative 3x and negative 3x the same term with different numbers. So we would again just put no solution, and we would not be able to graph it. And the last problem here is giving us a function. So it's talking about Antoine's class is selling candy to raise money for a class trip. They paid $45 for candy, and they are selling each candy bar for $1.50. So it gives us the function y equals 1.5x minus 45, and it says it represents their profit, which their profit would represent by y, and when they sell the candy, the candy is represented with X, or the number of candy bars is represented with X. So it asks us to find the 0 and describe what it means. And to go over what 0 means, the word 0 is actually the same as an x-intercept. Also, they call this a root, or they can even call it a solution. So all of these mean the same thing. So if we're asked to find the 0 of the function, think of it as asking to find the x-intercept. So the function again was y equals 1.50x minus 45. And if we're asked to find the 0, we need to find the x-intercept. It's the exact same thing. So the x-intercept, if I'm going to find that, which is what we talked about with the last lesson, I'm going to plug in 0 for y and solve for x. So I would need to move the 45 to be on the other side by adding it. So I have 45 equals 1.5x. And then I'm going to solve for x again to continue and divide by 1.5 to get x by itself. So x would be 45 divided by 1.5, which gives me 30. And then it asks us to interpret or describe what it means, which is kind of the same thing as interpreting the x-intercept. And we've done something like this before, so what we need to think about is what the x is represented in the problem, and then what would it mean if y was 0. So y in this problem, remember, represented the profit. So if the profit is 0 and I get 30 for my x, which represents the candy bars, what does that mean? That means that there's not going to be any profit at this point, but there's also not going to be any loss. And when you sell 30 candy bars, they call this breaking even, which is basically you've not made any money yet, but you've not lost any money because you've made all the expenses that you spent back. So we would say 30 in this case represents how many candy bars it needs for these people to break even, okay? That would be the best way to describe what that means in this particular situation. And that will conclude today's lesson.